Here's an example problem using the second derivative rule to find max and mins. And it still starts with finding critical points, letter A here. And we know critical points are defined as points where f prime of x equals 0. Or f prime of x is undefined. Okay? That said, we have a function here that is not going to have undefined. It's a polynomial. So we take the derivative using the power rule. 4 times the fourth is 1. We reduce the power of 4 to 3, so we get x cubed. Derivative of x cubed is 3x squared. The derivative of x squared is 2x. Now, this is no calculator, it says, so we have to factor. And again, 2 and 1 make 3. So I'll cheat. So I have an eraser board. Instead of writing another line, save a little space on the board here. And I can write x plus 2 times x plus 1. I know that this is that for the critical points, f prime of x will be 0. We set this product equal to 0. Obviously, the answers are x is 0, -1, and -2. Those are the critical points for letter A. They also become the points we want to check for the second derivative to locate the max and mins. And I said don't state max and mins, just state the x value of where they occur and justify your answer. Well, what we need to remember is the second derivative rule, or second derivative test. And it's that f prime prime is continuous. So we better get the second derivative, because it's the second derivative. So I'll take a derivative here. That's 3x squared plus 6x plus 2. It's continuous because it's a polynomial. There's no problem there. And around C, but that's continuous for all domain. And then it says if the first derivative is 0, the second derivative is positive, it is a local min. Well, that's because you think of positive, it's concave up. And the opposite is true. If it's 0 and concave down, it is a maximum. So that's our justification here. I'm going to do this with the table. I'm going to do this with the table. I'm going to send the page here. And I know my table is going to have x, -2, -1, 0. And I'll leave the other columns, but since this assignment was just for the second derivative rule, I could have just lived without x, but I need to have 0, 0, and 0. And then I'm going to plug the value -2 into the second derivative right here. So I get 12 minus 12 plus 2. I get a result of 2. All I care is that the result is positive. Likewise, when I plug in -1 into the equation, I find the result is negative. And when I plug in another 0 is positive, it's here. I tell you what, right away I know there's some points of inflection here because there's a sign change. I don't know where they're located, and I don't need to find them this time. It looks like I'd have to use the quadratic formula or complete the square to find solutions to that quadratic. But what I care about here now is just the reasoning. So, by second derivative rule, or test, I call it rule, f prime of -2 equals 0, and f prime of -2 is greater than 0, thus a local min. And I just stated the rule here for that. And again, if I copy this, I can get pretty lazy here actually. So all I'm going to do on the next two is just change a couple things. For the next reason, instead of -2, I'm checking -1, and -1 is less than 0. Thus, instead of being a local min, it's a local max. And likewise, the last reason, So again, this goes with this one. This goes with this one. This is going to go with this one when I correct some English in it. And instead of checking 2, I'm checking 0, and it is greater than 0, so it's still a local min. So there is a local max at x equals -1, and there are local mins at x equals -2 and 0. I didn't state the values. If I wanted to state the values, I'd have to go back to the original function. But as per the problem, it just asked me to locate the x values. Again, the second derivative test.